Hi, algebra students. We're going to be working on another method of solving systems of equations today, and it is called the substitution method. So I'm going to go ahead and share my screen so you can see the presentation. And I think it's worthwhile on this one to go ahead and pause the video and try these warm-up problems. And you can just use a piece of paper for this. All right, welcome back. So the warm-up asks you to solve each equation for x, because in the substitution property that we're going to use today, or the substitution method, let's go back here. You need to be able to get a variable all by itself. So in this first case, to get, it looks like to get x by itself, I would add 5y to both sides. Right, remember those aren't like terms, so I just leave it like that. You can put the y first, or you can just leave it as negative 29 plus 5y. The second one, to get x by itself, we add 9 to both sides. This time we can combine the terms, so we get x equals a positive 8. All right, let's look at our next slide. We have some vocabulary. This is on page 139 in your journal, so pause the video and copy these down, please. All right, welcome back. To solve a system of linear equations, or what is a system? It's a set of 2 or more linear equations with the same variables. And a solution is an ordered pair xy that makes all the equations in the system true. Okay, we did that with graphing yesterday, or the last lesson. And now we're going to be doing it with the elimination method. You have some notes on page 139 of your journal. It is the methods, or it's the explanation of how to solve a system of equations by substitution. So this is in your journal already. And then I would like you to add this step 4. So they give you 3 steps, step 1, step 2, step 3. I would like you to add step 4 there in the note section. So what we're going to do, we are going to isolate a variable. If it's already isolated, proceed to step 2. Substitute the value of your isolated variable into the second equation in place of the variable from step 1. You should now have an equation in one variable, all right? So back here, we're going to have x and y, and now when we simplify, we're going to be down to either just x or just y, and we're going to solve that equation. Then using that answer, we're going to substitute the value into one of the original equations to solve for the other variable, and then you're going to write your answer as an ordered pair. So it sounds more complicated than it actually is. So let's take a look at this first one. This is extra practice. This problem starts on page 140 in your journal. So let me grab my pen. All right, so it says solve. So when you're solving these, you always want to look for a variable that's easy to isolate. In general, you're going to look for one where a variable is all by itself. And when I say easy, it means, notice this doesn't have a 3 in front of it or something. If it had a 3, I would have to divide everything by 3 first to get this variable isolated. All right, I could also isolate this x by subtracting 5 from both sides. This one would be a little harder to get either x or y isolated. I'd have to do some division, right? So because this has y equals, and this y is all by itself here, there's nothing around it, there's just a 1 in front of it, this is what I'm going to use to substitute. So this tells me that y is equal to 5 plus x. That means anywhere on this page that I see y, I can replace that y with 5 plus x. This is the value of y. So I'm going to take this 5 plus x and I'm going to substitute it into the first equation in place of y. All right, so I'm going to write down what I have then. I still have my 2x in my first equation. I still have my 2 in the first equation, but now instead of y, since I know y is equal to 5 plus x, I'm going to replace y with 5 plus x. I need to be careful though, and I need to remember that the operation between this number and this variable is multiplication. So when I replace that y with 5 plus x, I need to remember that it's being multiplied by that 2 that's sitting out in front. All right, this is the step where it says you should now be down to one variable. If you notice our problem, we have an x and an x. We have gotten rid of the y values by using that substitution for y. So now I simplify and solve this equation. So I have 2x plus, here I'm going to use the distributive property, 2 times 5 is 10, plus 2 times x is 2x equals 10. All right, so I've eliminated the parentheses. My next step, of course, in solving an equation is to combine like terms. On this side, I have 2x plus 2x is 4x. I bring down my 10. I bring down my equals 10 on the other side. All right, so now I'm going to subtract 10 from both sides here. Those will go away. I bring down my 4x. On the right side of the equal sign, I have 10 minus 10 is 0. My last step here is to divide both sides by 4. 0 divided by 4 is 0. So I know my x coordinate of my solution is 0. Right, so off to the side here, just so I don't lose track of it, remember your solution is an ordered pair. Just like in the last lesson when we graphed the lines to find the solution, the point of intersection was an ordered pair, x and y. So in this case, I know my x value is 0. So I'm going to put it in the x position here. Remember, in an ordered pair, the x comes first. And I'm just going to leave a blank here because I don't know what my y value is. All right, but what I can do, and I'm going to switch colors here, to find the y value, in this case, I know x is 0. So that means I can replace any x in the problem with 0. So I'm going to put it in right here where we had y all by itself. So that means that my y is going to be equal to, and instead of 5 plus x, I now know that x is equal to 0. So my y value is equal to 5 plus 0, or just 5. And I'm going to put that into my ordered pair. All right, so we've been working mostly with the second one, right? We know that x was 0 and y was 5. This ordered pair 0, 5 should also work in this top equation. So let's see. 2 times 0 is 0. 2 times 5 is 10. And that's equal to 10. So it does work in both equations. So my solution is 0, 5. And that's the substitution method. Let's look at another example. All right, this time we have a y by itself here. I'm just leave that alone. Oh, I don't think I got the pen though. We have y by itself here. We could have gotten x by itself here by adding 2y. But since this y is already by itself, I'm going to use this substitution. So the y is equal to x plus 1. So in the first equation, I'm going to replace that y with x plus 1. All right, they've already given me a y all by itself. I know it's equal to x plus 1. So my next step is to actually do that substitution. Remember, you have to multiply these two things together. There's an implied multiplication in here. So when I rewrite it, I have x minus 2. And to keep track of my multiplication, I'm going to put a parentheses. The y is replaced by the expression x plus 1 equals -3. All right, now I'm down to an equation with just x's and constants. So I'm going to solve that equation. So I have my x. I need to distribute this -2 times x is a -2x. -2 times +1 is -2. And that's equal to -3 still. I'm going to combine these like terms. 1x minus 2x is a -1x, or just -x. Minus 2 is equal to -3, so I'm going to keep simplifying. Here, I'm going to leave this -x alone for now. I'm going to add 2 to both sides. So that leaves me with -x equals -3 plus 2 is -1. I want a positive x here, so I'm going to divide both sides by -1. And I get that my x coordinate is -1 divided by -1 is a +1. All right, so again, I'm going to write off to the side here. I know my solution has to be an ordered pair. I know my x coordinate so far. Sometimes you find the x first, sometimes you find the y first. These last two we found x's, so I'm going to put it in the x position. So I know my solution is 1 comma something. All right. Again, at this point, I'm going to switch colors. I'm taking this value of 1 because that's what x is equal to. And I'm going to replace x. And it doesn't matter which equation. It's just handy that this one has y all by itself. So I'm going to replace that x with its value, which we just found out was 1. So y is equal to 1 plus 1, or 2. All right, so my solution is the ordered pair 1, 2. Again, you can check by plugging these into either one of the equations and see if it's true. Let's try our first one. So my check here is going to be, is 1 minus 2 times 2, is that equal to -3? And in fact it is. 1 minus 4 is in fact equal to -3. So it works in both cases. And our solution is the 0.12. And again, remember, if you would graph these, this is where the two lines would cross at the 0.12. This is just saving you from having to graph everything. All right, let's look at our next example. All right, this time we have y isolated in both of them, right? So it doesn't matter where I substitute, right? I know y is equal to 2x plus 8. I know y is equal to -2x. So I can either put this 2x plus 8 down here for this y, or put this -2x up here. It doesn't matter. I'm just going to go ahead. I know y equals 2x plus 8. I'm going to replace that y with 2x plus 8. Whoa. I don't know what I did. Okay. All right, I'm going to go back and forward here so we can clean that up. All right, again, I'm going to grab my pen. My pen went haywire there for a minute. All right, so again, I'm taking 2x plus 8, and I'm going to substitute it in for this y. All right, y is equal to 2x plus 8. So now I write down 2x plus 8 equals -2x. So again, notice when I do that substitution, when I substitute for the variable, I get down to just one variable and some constants. All right, so I'm going to subtract 2x here. I'm trying to solve for x. So I want x's on one side and constants on the other. All right, so that's gone from here. That leaves me with 8 is equal to -2x minus 2x is a -4x. Divide both sides by -4. And I'm going to get that x is equal to 8 divided by -4 is -2. All right, again, write down your solution. Write down what you know so far. It'll help you keep track of finding both variables. So again, this is an x we found was -2. I'm going to switch pen colors to find my other point. So x this time is -2. I'm going to take that -2 and plug it in for x. Notice I could have plugged it in for either one, but since this one was circled, I'm going to use it, but I could certainly put it right here. So let's see, our y is equal to 2 times, we said our x value was -2 plus 8. So our y is equal to 2 times -2 is -4, and -4 plus 8 is equal to a +4. Notice I would have gotten the same answer if I had plugged it in here. I'll just do this as a little aside. I could have just done y equals -2 times -2 and gotten my +4 that way. All right, once you find the variable, it doesn't matter which equation you plug it into to find the other. So my solution is the ordered pair -2, 4. All right, because that solution works in both equations. All right, extra practice number 9. Again, look for a variable that's isolated. In this case, I see that y is equal to 4. So this one's nice. I actually can go down to my solution because this tells me my y is the number 4. So I'm just going to put it in here. My y is equal to 4. I don't know why it keeps doing this. I'm going to go back. I'm going to write my solution. I know my y value. Is 4, so I'm going to put that in the y position. So in this case, I just need to figure out what my x is. All right, my y is 4. So in that top equation, I'm going to substitute 4 for y. So I'm going to rewrite that top equation. It is now 2x minus 3. Remember, this is multiplication, so minus 3 times 4 is equal to 0. So I simplify, solve this equation. 2x minus 12 is equal to 0. Add 12 to both sides. Remember, I'm solving for x this time. I already know my y. I get 2x is equal to 0 plus 12 is 12. Divide both sides by 2. And my x value is 12 divided by 2, which is 6. So my solution is the ordered pair 6, 4. All right, we already know it works here. 4 equals 4 when I replace the y. In the top one, let's double check, is 2 times 6 minus 3 times 4. Is that equal to 0? All right, I want to make sure I'm right. So let's see, 2 times 6 is 12. 12 minus 12 is in fact equal to 0. So our solution of 6, 4 is correct. All right, so that's the substitution method. Your assignment today is in your book. There's links to the book on Schoology. It is lesson 5.2 on page 245, and you are to do problems 9 through 14. Be sure to show your work. Be sure to write your answer as an ordered pair. If you have any questions, shoot me an email. Good luck.